Okay, now I'm showing you how to do assignment 7.1. We are using Map Viewer, the new version. You're bringing in that layer that I created that has the watersheds and the stream length for each watershed. That's what we're going to use as our data, the stream length in miles. And when it comes in, of course, it's defaulting to this graduated symbols, and we're going to go ahead and change it over. And remember, with this, it turns out that they just changed this. I think we can actually replicate layers in Map Viewer now, but we couldn't at the time of this assignment. So we had to bring it in 4 different times. In the classic viewer, you can actually replicate them, but and supposedly now in the new viewer you can too. I haven't tried it yet. But just showing you what the data look like. It's just the watershed data, and then I added in how many line segments were streams and how many total miles you had in stream length. That would be all the main branches and all the tributaries in each of those watersheds. So I'm going to rename each of the layer according to the classification that I'm going to use, and we've talked about natural breaks and equal interval and quantile and standard deviation, just like the ones covered in the chapter. So the first thing we have to do is to change the style over to actual this style, okay, not the style where you have graduated symbols. This is what we call graduated colors. And we're changing it defaults to 4 classes. We're changing it to 5. So, and then you can see the histogram there. You can kind of see it's using some algorithm for coming up with those dividing lines between the 5 different classes. It's called the Jenks classification method. Equal interval is a little bit more straightforward. It's just dividing everything into 5 equal classes. So when we change it over to that, and this is where some of you messed up. You kept the natural breaks for all of them. You forgot to change the classification type. And so you do this, and then you have to classify the data, and now you actually have to do everything all over again, but now change it to equal interval and change the number of classes to 5. And you can see they're basically just 20. In between all of them. It's not perfectly 20 because the top number is 101, not 100. Then the next time we're doing the quantile, which you learned how that gets divided up in the chapter in section 7.1. And so we're doing the quantile method, but once again with 5 different ranges. And so we've got that one. And then the last one, we're doing the standard deviation. So we're changing that system over to standard deviation. Right there. Boom. Standard deviation. And we're just going to stick with the 1 standard deviation in terms of the how it's breaking them up. So now we've got our 4, it's 1 map with 4 different layers, and you can, just turn them on and off by using the little hide button, the little eyeball, and see how they differ with each other. So you were supposed to look at the histogram, which is the chart we're going to make next, to see and be able to defend which of those 4 methods you think actually does the best job of explaining to your user group what the variation is in that particular. And obviously it should be kind of related to the size of the watershed, you would think. So to do this, you would add a chart. And most folks did this just fine. The chart really wasn't a problem. You went and picked histogram, and then you just picked a couple of the different options. You had to tell what number to use, and we were using the summarized length in miles. And then coming down, I told you to pick 10. I wanted you to have 10 bins or 10 groupings. So you can start to see the normal distribution. So you can see that it is pretty normally distributed. So that should have been maybe a hint for which method might be the best. But as long as you defended any of your methods, you got full credit. I wasn't too fussy on it. And the standard deviation, because it is normally distributed, might actually be the best, but it's one that's hard to understand. So perhaps that quantile might have actually been a little bit better. Jenks doesn't use the normal distribution, so maybe it wasn't the best. So the quantile might have been a better one to use because it would be more based on the distribution of the data. And there you go.